January 1st, 2019, tomorrow, will be a really important day in space exploration. The greatest thing that's going to happen tomorrow is the tiny spacecraft New Horizons, about the size of a piano, which flew by the dwarf planet Pluto in 2015, is going to fly by a tiny Kuiper Belt object nicknamed Ultima Thule, which is really 2014 MU69. But how is it that we know exactly where this is? Now, New Horizons, when it flew by Pluto, it had 100 years of data to work with and figure out exactly where it was by plotting all of the various tracks. Using this, we could get a really high estimate of where this object was. Thus, we were able to fly by it with a high degree of accuracy and produce some really stupendous images. But even with all the knowledge that we have about Pluto, we only really know where it was to within a couple 100 kilometers roughly. Now, with the distance that we flew was so that we could get good information on both Pluto and Charon, but still we were able to get some absolutely spectacular images from that dwarf planet and its moon Charon. But how is it that we know where this object, 2014, as in the real name of the object, is the year it was discovered? So instead of having 100 years worth of data, we only have 4.5 years worth of data to be able to track this object. So they had to really come up with something new. Now, Ultima Thule, as I'll call it for the rest of this time, although it'll probably be given another name later, is a very small, very dim object that's very, very difficult to detect. The New Horizons team has tried to image this using ground-based imagers, and they have failed. The reason is this object is inside of the galactic center. It appears in the same part of the sky as the galactic center. There's a whole bunch of stars there, and it just kind of gets washed away if you're looking at it through the atmosphere, even with the absolute best of ground-based telescopes. So there's only 2 telescopes that have been able to successfully see this object. The first one, and the one that found it in the first place, was the Hubble Space Telescope. And that one has provided a lot of data that has been used throughout everything. LORRI, the spacecraft's telescope, has been able to image it for about 1.5 years or so, and has been providing a little bit of extra data that could really help. The first step that you have to do is take the images with the Hubble Space Telescope and figure out exactly where it is. How accurately does Hubble Space Telescope know where it is? Well, there's a couple of things that you need to know. First of all, how accurate is a single pixel on Hubble? And the answer is about 1,600 kilometers when you're looking at a distance as far away as Ultima Thule is. Now, there are a couple of issues that we still need to know. First of all, we can actually improve the accuracy quite a bit by using what's known as a point spread function. If you have a tiny point of light that's so far away that all you will see is a tiny pinprick of light, you can actually identify where that light's coming from a little bit better than just 1 pixel's worth of resolution. You can imagine that if you shine a light that's exactly on the corner of the pixels, that the 4 neighboring pixels are all going to show up brighter. If you shine it right in the middle, it's just going to show a bright light on the center pixel and not as bright on the neighboring pixels. This is because there's a little bit of bleed, and using the knowledge of Hubble, we can actually improve the estimate of where it is down to something about 1/10 of a pixel, so about 160 kilometers. That would be really fantastic if we could figure out the object's distance that accurately. There's a couple of issues. First of all, that's only the point of where it is on the sky. Now, if we're actually going to track where it is, we have to keep a large arc of this so that we can get a better certainty as to where it actually is. You see, basically the sky is essentially 2-dimensional. You have a right ascension and a declination, and you can tell where it is given your 1 point, but New Horizons needs to know where it is in 3 dimensions, including the distance. The distance isn't such an easy thing. It's actually a very, very difficult thing to find using astronomy. If you were going to use something from the ground, you'd point a laser at it and you could figure out exactly where it is. We can do the same thing with the moon and find out with really high precision exactly where the moon is. There's a couple of other ways that you can refine this trajectory, but the way that the New Horizons team is doing it is using a whole bunch of points of where it is along the orbit, and with each one of these points they're able to put it into a formula taking into account the orbit of Hubble, the orbit of the Earth, and the orbit of this object, and figure out exactly what its orbital trajectory is. Okay, so this gives you a first estimate that's maybe a couple 100 kilometers off. Now, how can we improve this? Well, the more time we have, the better our estimate is. So they continue to refine all of this data through more experiments. Now, one of the big sources of errors, though, lies in Hubble itself. Hubble is able to maintain its relative pointing absolutely spot on. It can point at a specific point in the sky for minutes and not lose track of it. Just for example, to take the pictures of this tiny, tiny Kuiper Belt object, it had to point for a total of 6 minutes each. And given all of that, it was able to image at just a tiny, tiny pinprick that's barely visible. But what we can do is use the stars that are in the background to get a better idea of exactly where it is. Now, Hubble is actually tracking the motion of this object so that the object itself is going to have the best point spread resolution. That's what you want when you have such a dim object. But if you compare it to the stars that are in the same field, you can figure out exactly where it is. But how do we know where the stars are? Well, if you look up at the night sky, the stars appear relatively fixed. But the truth is that they're actually moving very, very slight distances every night. And it can actually make a real difference. Now, there have been some studies that have gotten some data as to which stars are moving, and we can actually know with a fairly high degree of certainty where these stars actually are. There's a survey that just barely was released by ESA that actually cataloged many of the major stars in the sky and what their relative motions are. And so the New Horizons team made a request from the team that was putting this together to get a hold of this data early, and with this earlier data they were able to exactly identify where the stars were and make sure that they're getting this super accurate information. Now there's a second really interesting thing that they could do. Given all of this data, they were able to improve the uncertainty to maybe 50 kilometers or so, but that's still quite a far distance. That's about the size of the object itself, roughly. What they were able to do, though, is to predict some stellar occultations. Now basically, when an object passes in front of a star, it will cast a shadow. The easiest example to see of this is during a total solar eclipse. When the moon passes in front of the sun, it casts a shadow that you can see from Earth, and the light of the sun is blocked out. You can get some really great data as to how big an object is when you have one of these occultations that happens. Now, how are we actually going to predict this? As the motion of the Kuiper Belt object, Ultima Thule, goes across the sky, it will in fact pass across a couple of stars occasionally. And some of these are bright enough that the stars can be observed from the surface of Earth. But we need to be able to predict where it is. This shadow, as it really is, from this tiny object will only be about the size of the object in its size as seen from Earth. Therefore, we need to be really, really close to be able to figure this out. We need to have its uncertainty very tiny. So they were able to identify some instances where they felt like the shadow would pass through. The first one they actually missed entirely. It appeared so far out that they just couldn't see it. As they improved their predictions, they were able to narrow down and get the uncertainty down to maybe 10 kilometers or so, which is actually really, really fantastic. Now, this is the uncertainty of the shadow as it appears from Earth. It still doesn't completely get the range piece of it, but they're able to know where it is in the sky. And so New Horizons, while imaging its target, was able to really improve this pass even further. And the spacecraft dynamics team was able to predict a path where they were going to pass along the object. And so what they're going to do, it's kind of a tube-shaped uncertainty as to where it is. The range is a much more uncertain thing than its absolute distance. So they're going to take a bunch of pictures in this path and hoping that they collect the right one, and they really should. Now, hopefully they've done all their math right, and they'll pass by and take some absolutely fantastic pictures in the early morning of January 1st. It's going to take a long time to receive this. This is really a once-in-a-lifetime chance. There probably isn't going to be another spacecraft that'll visit a Kuiper Belt object in the next 20 to 30 years. There's nothing on the plans that I'm aware of. So to do this right, they really had to get everything right. Their size of this object is much smaller than the size of Pluto and Charon, so they were able to carpet a whole bunch of images, and hopefully some of those will in fact be the right spot-on ones. And the better you know this, the better you can improve things. Using a stellar occultation, they were also able to improve the size. There's 3 ways that you can know the size of an object. The first one is to have a resolved image of it. So we could take a spacecraft telescope of some kind pointed at Mars, and we can get a pretty good idea of how big Mars is. The second way you can do it is using some kind of an infrared telescope. Infrared will release heat more consistent with the size of the object than the visible light. The visible light, if you have something that's really reflective but tiny, it will produce the same amount of light as something that is big but dimmer. It turns out that Ultima Thule is a very dark object. So because they were able to identify the size from this occultation project, then they were able to better set the instruments to take the right amount of exposure and produce the best images they possibly can. Hopefully all of this math has been done correctly, and the New Horizons team will have a successful flyby of Ultima Thule. When this is released, we'll know about 24 hours later whether or not the spacecraft survived this encounter, and we'll start to get the data back over the course of the next year and a half, roughly. I'm really excited to see what kind of data this flyby will produce. It should be absolutely fantastic, and I'm really looking forward to seeing this little tiny object in the outskirts of the solar system. This is one of the pristine building blocks of the solar system. And so hopefully by studying this, we can understand more about how we all came to be here on this planet. Thank you very much for joining me. Good luck to the New Horizons team on your flyby. Let me know whatever questions or comments you guys have about space exploration or any other topic. Let me know what your mission that you're looking forward to that's coming up in the next few days. I'm Ben Pearson, the Roadster Tracker, and until next time, keep on tracking. Take care.